together, then this bar actually rolls back from the others down the cardboard. If I were to break these bars into 1,000 pieces, each piece would still have two poles, and if they were scattered about near each other in such a way that they were quite free to move, they would arrange themselves always so two different poles came together. Now picture to yourselves that all the particles of those substances which form crystals have poles like our magnets, and you can imagine that when the heat which held them apart is withdrawn and the particles come very near together, they will arrange themselves according to the attraction of their poles, and so build up regular and beautiful patterns. So if we could travel up to the clouds where this fairy power of crystallization is at work, we should find the particles of water vapor in a freezing atmosphere being built up into minute solid crystals of snow. If you go out after a snow shower and search carefully, you will see that the snowflakes are not mere lumps of frozen water, but beautiful six-pointed crystal stars, so white and pure that when we want to speak of anything being spotlessly white, you say that it is white as snow. Some of these crystals are simply flat slabs with 6 sides. Others are stars with 6 rods or spikes springing from one center. Others with 6 spikes, each formed like a delicate fern. No less than 1,000 different forms of delicate crystals have been found among snowflakes, but though there is such a great variety, yet they are all built on the 6-sided and 6-pointed plan, and are all rendered dazzlingly white by the reflection of the light from the faces of the crystals, and the tiny air bubbles built up within them. This, you see, is why, when the snow melts, you have only a little dirty water in your hand. The crystals are gone, and there is no more air bubbles held prisoners to act as looking glasses to the light. Hoarfrost is also made up of tiny water crystals, and is nothing more than frozen dew hanging on the blades of grass and from the trees. But how about ice? Here, you will say, is frozen water, and yet we see no crystals, only a clear, transparent mass. Here again Dr. Tyndall helps us. He says, and as I have proved it true, so may you for yourselves if you will, that if you take a magnifying glass and look down on the surface of ice on a sunny day, you will see a number of dark, 6-sided stars looking like flattened flowers, and in the center of each a bright spot. These flowers, which are seen when the ice is melting, are our old friends the crystal stars turning into water, and the bright spot in the middle is a bubble of empty space, left because the watery flower does not fill up as much room as the ice of the crystal star did. And this leads us to notice that ice always takes up more room than water. And this is the reason why our water pipes burst in severe frosts. For as the water freezes, it expands with great force, and the pipe is cracked, and then when the thaw comes on and the water melts again, it pours through the crack it has made. It is not difficult to understand why ice should take more room, for we know that if we were to try to arrange bricks end to end in star-like shapes, we must leave some spaces between, and could not pack them so closely as if they lay side by side. And so, when this giant force of crystallization constrains the atoms of frozen water to grow into star-like forms, the solid mass must fill more room than the liquid water, and when the star melts, this space reveals itself to us in the bright spots of the center. We have now seen our drop of water under all its various forms of invisible gas, visible steam, cloud, dew, hoarfrost, snow, and ice, and we have only time shortly to see it on its travels, not merely up and down as hitherto, but round the world. We must first go to the sea as the distillery, or the place from which the water is drawn up invisibly, in its purest state, into the air, and we must go chiefly to the seas of the tropics, because here the sun shines most directly all year round, sending heat waves to shake the water particles asunder. It has been found by experiment that in order to turn 1 pound of water into vapor, as much heat must be used as is required to melt 5 pounds of iron. And if you consider for a moment how difficult iron is to melt, and how we can keep an iron poker in a hot fire and yet it remains solid, this will help you to realize how much heat the sun must pour down in order to carry off such a constant supply of vapor from the tropical seas. Now, when all this vapor is drawn up into the air, we know that some of it will form into clouds as it gets chilled high up in the sky, and then it will pour down again in those tremendous floods of rain which occur in the tropics. But the sun and air will not let it all fall at once, and the winds which are blowing from the equator to the poles carry large masses of it away with them. Then, as you know, it will depend on many things how far this vapor is carried. Some of it, chilled by cold blasts, or by striking on cold mountain tops as it travels northward, will fall in rain in Europe and Asia, while that which travels southwards may fall in South America, Australia, or New Zealand, or be carried over the sea to the South Pole. Wherever it falls on the land as rain, and is not used by plants, it will do one of two things. Either it will run down in streams and form brooks and rivers, and so at last find its way back to the sea, or it will sink deep in the earth till it comes upon some hard rock through which it cannot get, and then, being hard pressed by the water coming on behind, it will rise up again through cracks and come to the surface as a spring. These springs again feed rivers, sometimes above ground, sometimes for long distances underground, but one way or another, at last the whole drains back into the sea. But if the vapor travels on till it reaches high mountains and cooler lands, such as the Alps of Switzerland, or is carried to the poles and to such countries as Greenland or the Antarctic continent, then it will come down as snow, forming immense snow fields. And here a curious change takes place in it. If you make an ordinary snowball and work it firmly together, it becomes very hard, and if you then press it forcibly into a mold, you can turn it into transparent ice. And in the same way, the snow which falls in Greenland and on the high mountains of Switzerland becomes very firmly pressed together as it slides down into the valleys. It is like a crowd of people passing from a broad thoroughfare into a narrow street. As the valley grows narrower and narrower, the great mass of snow in front cannot move down quickly, while more and more is piled up by the snowfall behind, and the crowd and crush grow denser and denser. In this way the snow is pressed together till the air that was hidden in its crystals, and which gave it its beautiful whiteness, is all pressed out, and the snow crystals themselves are squeezed into one solid mass of pure, transparent ice. Then we have what is called a glacier, or river of ice, and this solid river comes creeping down till, in Greenland, it reaches the edge of the sea. There it is pushed over the brink of the land, and large pieces snap off, and we have icebergs. These icebergs, made, remember, of the same water which was first drawn up from the tropics, float on the wide sea, and melting in its warm currents, topple over and over,